Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Let's get going right away today as we work to apply our properties of exponents. We need to be able to handle a multiplication of powers, right? And how we can use our shortcut rules to simplify that expression. A power of powers, right? And number two, when we take a power and raise it to an exponent, how we can simplify, and then combinations thereof, like number three. So let's go ahead and take a look. In the first problem, there's no parentheses. And so it's important to note that those exponents only apply to the factor that's right next to the exponent. And so in other words, the 2 is not cubed in that first expression, only the x is cubed, and so on. And the 4 is not raised to the 5th power, only the x is raised to the 5th power, right? So we could regroup those factors in any order with multiplication. 2 times 4 is 8. And x to the 3rd times x to the 5th. If we were to expand this first power out, we'd have 3 x's multiplied together. If we were to expand the second power out, we'd have 5 x's multiplied together in a row for a grand total of how many x's? 8 x's. So 8x to the 8th would be my final answer. Raise your hand if you already had that. So 8x to the 8th. Good job, you guys. Way to go. One of your quiz questions looks just like that with different numbers, right? One of your quiz questions look just like that. So if you can do number 1, then you're 1 down on your quiz. What's different about number 2? Now there is parentheses, and so if there are parentheses, then everything in that quantity is going to be raised to the 5th power, which means it's not just 2x, right, to the 15th when we do our shortcut operation and raise a power to a power we multiply exponents. The 2 is also raised to the 5th power because there's parentheses, and so this is like 2 to the 5th times x to the, and remember our shortcut operation there when we when we take a power and raise it to a power is multiplication, so that's x to the 15th. So my final answer we could write as 2 to the 5th, contrary to popular belief, is not 10, right? It's 2 multiplied by itself 5 times, so that's 32x to the 15th. Please raise your hand if you already had that. Yes, hey! One of your quiz questions looks exactly like number 2. Go with different numbers. So you guys are 2 for 2 so far. All right, and number 3 then is a combination thereof. And so we've got a product of powers. We've got a power raised to a power, so let's go ahead and show our work along the way. Before we can combine those into a single power of x, we need to get rid of the parentheses. So we'll leave that 5x to the 4th chilling out front. We'll leave that 5x to the 4th. And now we'll go ahead and simplify the parentheses there. So I have 3x cubed all squared. If there are parentheses, then everything in the parentheses is going to be squared, which means that the 3 is squared and the x cubed is squared. Keep in mind when we take a power and raise it to an exponent, our shortcut operation is multiplication with the exponent. So this becomes x to the not 5th, right? It's x to the 3 times 2 is x to the 6th. We'll go ahead and regroup. I've got 5 times this 3 squared is 9, so I've got 5 times 9 is 45, and then I've got x to the, now there's no parentheses, so I've got 1, 2, 3, 4 x's multiplied together. I've got 6 x's multiplied together. How many x's do I have multiplied all together? Ben? 10. And so my final answer would be 45x to the 10th. Did anybody get that? Raise your hand. You got that? Hey, that's good news. And yes, you guessed it. There's a quiz question like this.
Oh my God.
What's different numbers? Are you 3 for 3 so far? Right? You can be 3 for 3 on your quiz. All right.
Speller should just be the quiz.
Could we add this for the quiz? No, but this is a great review for your quiz. So this is very similar to the first part of your quiz. All right. So we also need to be able to handle negative exponents, and we could rewrite that as a reciprocal. Remember, negative exponents don't mean negative answer. They mean reciprocal. M to the negative 7 is the same as 1 over m to the positive 7. However, because there's multiple powers of m right now lined up, I think it's easiest to apply our addition property of exponents. When we multiply powers together that have the same base, we can simply add the exponents. And so I think it's easiest instead to go ahead and rewrite this as a single power of m and add my exponents. That is to say, 3 plus negative 7 plus 0, right? We can do that product of powers and add my exponents all together. So it looks like I get m to the 3 plus a negative 7 is negative 4 plus 0 is negative 4. And now we want to write our final answer with positive exponents. And so it's typically bad math manners to leave your final answer with negative exponents unless asked to. One section of the homework did ask you to write with negative exponents, so there weren't fractions anymore to work with the property. But in general, we want to write our final answers, particularly on the quiz, with positive exponents only. So we want to make sure that you don't leave your final answers with any negative exponents on the quiz for full credit. So m to the negative fourth doesn't mean a negative answer, it means reciprocal. I know that m to the negative fourth is the same as 1 over m to the positive fourth. And so I hop the line and change the sign. That is, hop the line, go across the fraction bar, and then change the sign on the exponent, right? It was a negative 4 exponent, now it's a positive 4 exponent after I've made the reciprocal. This is my final answer, 1 over m to the fourth, and that's what we got. What questions do you have about our first 4? Katie?
Would it work to write m to the negative fourth? The last one.
No, because it's bad mathematics. Just like we don't write x2 plus 7, we write 2x plus 7. Same thing. Now, you'd still get partial credit for applying the property correctly, but your final answer should have positive exponents only, unless asked for. Like I said, that one section of your homework asked you to write with negative exponents for your final answer. In general, you don't want to leave it with negative exponents. Good question. Other questions about 1 through 4? Then let's take a look at our solving. Oh, no, we got one with fractions. Oh boy. So let's put it all together and see if we can handle something like number 5. And so we've got product raised to power. We've got negative exponents, and we've got a fraction. So let's go ahead and go step by step. The first thing I'll do is get rid of the fractions. Then, I'm sorry, the parentheses rather. Then I'll go ahead and apply my negative exponents by hopping the line and changing the sign. And then lastly, I'll go ahead and condense any powers where I have multiple powers with like bases appearing. So ready? First step, let's get rid of the parentheses. So 2x cubed means that everybody in that first parentheses, 2x, gets cubed. So 2 gets cubed, x gets cubed. There's my first power. I'll leave y to the negative fourth for the time being, knowing that I'm going to apply the negative exponent next. Is the 16 squared? Right? Is that 16 squared, Brady?
No,
How do you know it's not squared?
because it's not in parentheses.
Good. So if in the absence of parentheses, right, the only thing that's raised to an exponent is the thing that's right next to it. The xy are in parentheses, they're squared. The 16 is not. So I'm going to leave the 16 alone, just chill. And now I'll go ahead and apply the exponent, that squaring, to the product xy. Here we go. What gets squared? They both do. X squared, y squared. So we've gone through and we've gotten rid of the parentheses. The next thing we're going to do is apply our negative exponent property. Our negative exponent property doesn't mean negative answer, it means reciprocal. So we'll hop the line and change the sign. Any power that currently has a negative exponent is equivalent to the positive exponent, but on the other side of the fraction bar. So I'm going to leave the 8x cubed alone for right now. I'm going to leave that as 8x cubed, but I'm going to grab onto this y to the negative 4, and I'm going to kick it on down to the bottom as y to the positive 4. So once again, any power with a negative exponent is equivalent to its reciprocal with the positive exponent. So a negative exponent means reciprocal. Meanwhile, I still have 16 on the bottom. I still have x squared on the bottom. I still have y squared on the bottom. Now, finally, we can reduce our fractions. So we've got 8 over 16. We know that 8 over 16, dividing out a common factor of 8 is the same as 1 over 2. So on top I have 1, on bottom I have 2. Now I'll go ahead and focus on my x's. Do I have more x's on top or on bottom? Adam? By how many, Margot?
5, 3, 2, 1.
By 1, and so my final answer will just have x to the first on top. Good. So I've taken care of the 8 and the 16, the x cubed and the x squared, and then I have that y squared and y to the fourth on bottom. All of my y's are on bottom. How many y's do I have on bottom in all? Eric? 6. Good. So y squared times y to the fourth is y to the sixth. So my final answer, we don't have to write that 1, would be x over 2y to the sixth. Nice job. Good work, you guys. What questions do you have about number 5? I tried to show step by step. 1, get rid of the parentheses. 2, apply your negative exponent properties. 3, simplify the fractions. All right, number 6, please solve. Oh, this is a blast from the past. Don't write x squared plus 49. right? We cannot distribute an exponent through the parentheses if there's a sum or difference. And this is exactly what people did on their Unit 1 test and lost points. And so you cannot distribute an exponent through the parentheses if there's addition or subtraction. This is not equivalent to x squared plus 7. In fact, your 20 stamp on yesterday's activity was a plus b in parentheses times a plus b in parentheses. That's what it means to be a plus b squared. So this would be x plus 7 times x plus 7, and we don't have a method for multiplying that yet. Instead, think about your forward steps and your reverse and undo to get your solving steps. Since x only appears once, not in the bottom of a fraction, I can cover up my equation and focus on my expression that contains my variable concern and list my forward steps. I'm ready to go. Ready? First step, plug in something for x. To evaluate, my first forward step would be add 7. So my forward steps are add 7 and then square it, or raise to the second power. Reverse and undo to get my solving steps. My first solving step needs to undo squaring. What undoes squaring? Taking the positive and negative square root. Remember, when you're the one creating the radical, to undo squaring, that's when you have to include the two, positive and negative. And lastly, undo addition of 7 by subtraction of 7. So my forward steps, reversed and undone, become my solving steps. Let's apply them in order. First step, take the positive and negative square root of both sides. That gets my quantity x plus 7 out of the parentheses squared, and now I have plus and minus square root of whatever was there. Sometimes, in this case, it was 11. Sometimes it'll reduce, sometimes it won't reduce. But either way, I'll be able to break it up into two separate paths. One path is x plus 7 equals the positive square root of 11. One path is x plus 7 equals the negative square root of 11. I'm going to have to fix that because I can't quite see that that's plus and minus square root of 11. There we go. Now we'll go ahead and finish it out. My last solving step was subtract 7 from both sides. I just do it to both equations in both paths on both sides. So here we go. Minus 7, x equals negative 7 plus root 11. Minus 7, x equals negative 7 minus root 11. It's easy to see we have not one but two solutions. Even though they're irrational, that is to say, as a decimal approximation, these values of x would go on forever and ever without stopping or falling into a repeating pattern because this contains a non-perfect square factor inside the square root. There are still two real numbers, right? And we could get a decimal approximation if we wanted to know about what that was. In any case, we'll box these. And know that it's okay if we don't get a whole number or a fraction for an answer. That's okay. Heather.
Does the square root have to come after the...
Nope, you could have root 11 minus 7 or negative root 11 minus 7. You could even have minus 7 plus or minus root 11. That would be okay as well. Adam.
So you don't have to break it up.
You don't have to break it up. Just so long as you have the plus or minus, you can still get full credit. However, I purposely break it up, 1, because we did in the activity, and 2, because right now it's easy to see you've got two solutions. Right? And it's easy to see what they are if you wanted to get a decimal approximation. You can just enter that in your calculator, enter. Put that in your calculator, enter. See what I'm saying? Other questions about your Bellwork? All right, let's get you credit for your... Oh, no, I want you to go ahead and talk about the difference between these powers. And so right now, you're going to turn to your partner, and you're going to talk about the difference between these powers. That is negative 9 squared versus negative 9 squared, 2w squared versus 2w squared, and then negative 5q to the 0 versus negative 5q to the 0 versus negative 5 to the 0. Okay, so go ahead and turn to your partner right now and be ready to share your response with the whole class how they're different.
And then the next one's going to be 9 times 9 times that. If you do that, you end up doing
Well,
not really squared separately because the 2 in the second one isn't squared.
So we
We know.
And then the -5 gives 0, it goes to -5.
No, it just goes to, it just goes to.
Yeah, it's just positive.
Okay, ladies and gentlemen, please be ready to share the difference between the first two powers, that is -9 squared versus -9 squared when I call on you. So what's the difference between these first two powers only, the first two powers? Carson and Dakota? Are they the same? All right, would these give us the same values? No, how come?
Wouldn't the first one be positive, and then the second one is negative?
Raise your hand if you think the first power is positive, as Carson suggested, and the second power is negative. You're correct. Yes, the first one would be positive, right? How come? In the first one, the base is -9 multiplied by itself 2 times. Remember, the exponent tells us the number of times the base will be multiplied by itself. In the second one, there are no parentheses. And so, in the absence of parentheses, the only thing that's raised to the exponent is the factor that's right next to it. And so the negative is not squared in that second representation. It would be negative times 9 times 9. And my order of operations right here, -9 times -9 in the first one gives me a positive 81, versus negative times 9 times 9 gives me a negative 81. So these are two very different results because of those parentheses right in my order of operations. Nice job. Raise your hand if you have 81 and -81. 81 and -81 respectively. Nice job. Let's take a look at the second one. What's different about the second one? Go ahead and tell the class of my colony. So what's different about the second one? Right? Heather and Marina?
The first one, everything is squared, and the second one, W does.
Absolutely. In the absence of parentheses, only the factor right next to the exponent gets raised to that exponent. In the first one, there are parentheses, so everybody in the parentheses gets raised to the second power. So yes, this would be 2 squared times W squared, which in turn would equal 4W squared, versus this one would remain 2W squared. So 4W squared versus 2W squared. Awesome. Good job. And lastly, what's the difference between these three expressions? They all have negative exponents. I'm sorry, they all have 0 exponents, right? But their values may or may not be the same. Caitlin? The first one is 1, I agree. And why is the second one -5?
Because it doesn't have parentheses, so you don't put parentheses.
Absolutely, Caitlin. In the absence of parentheses, the only thing raised to the exponent is the factor right next to it. So the -5 is out front, just chilling, with the operation multiplication times whatever follows. Q to the 0 is 1, so -5 times 1 is -5. Nice job. And lastly, parentheses, so everybody's raised to the exponent, so this would be 1. Let's see if we can't. There we go. There we go. Awesome. Way to go. What questions do you guys have about the difference between these expressions? And let's go ahead and deal with negative exponents together first before we check our homework. So this is important. On your quiz, you'll have to rewrite with positive exponents. And so if you're given an original expression, p to the -2, its value, right, its value doesn't mean that it's going to be negative just because there's a negative exponent. Instead, negative exponent means reciprocal. So to rewrite this with positive exponents, I'll simply write the reciprocal raised to the positive exponent. P to the -2 is equivalent to 1 over p to the +2. That is, I can hop the line and change the sign. Hop the line where the line's the fraction bar and change the sign, that is, switch the sign on the exponent. That's it. Done. Stick a fork in it, because that's finished. You'll have to do that on your quiz. Next, 3r to the -2. What is raised to the -2 power? The 3 or the r or both? Tyler?
R.
Only the r, thank you. In the absence of the parentheses, only the factor right next to the exponent gets raised to that power. So 3 stays just chilling. In fact, the 3 stays on top, and the r has to do the reciprocal. The r is going to hop the line and change the sign. So my final answer would be 3 over r squared. That is, r to the positive 2 on bottom is equivalent to r to the negative 2 on top. Do you see why the 3 stays? Awesome. And 1 to go. In the absence of parentheses, the only thing, right? The only thing that's raised to an exponent is the factor that's right next to it. So is the negative 5 raised to the negative third power? No. Is the x raised to the negative third power? No. So those are still there. Is the y raised to the negative third power? Yes. And so my y power, y to the negative third on top, is going to hop the line and change the sign. It's going to become y to the positive third on bottom. Everybody see that? So we've hopped the line and changed the sign. Go Gadron. Similarly, the a to the negative fourth power is equivalent to a to the positive fourth on top. I hop the line and change the sign on the exponent. The b is going to remain. So I've written those quantities that remain in the same green color. They're not moving at all because they didn't have negative exponents. Everybody see that? They're staying put. All right, now we can probably rewrite this to make it a little nicer. Typically, when we have multiple variable expressions, right, we can do sort of alphabetical order, but it doesn't matter. I would probably put negative 5a to the fourth x over by cubed. And that negative could go out front of my fraction, or it could go on top as a single negative, or on bottom as a single negative. We just couldn't put it in both places, then it would be positive. So that negative could be written out front. In fact, maybe I'll do that. Ooh. So that equals negative 5a to the fourth x over by cubed. Do we see that? So in order to manipulate negative exponents, we'll hop the line and change the sign. Negative exponents don't mean negative answers, they mean reciprocal. Great. Let's go ahead and take care of our homework then. Ladies and gentlemen, take out your homework assignment number 1. That's the worksheet. If you showed me your 7.2 and 7.3 reading questions, you'll be eligible for the 5th point. If you did 1 reading question, you'd be eligible for additional plus 1/2 or plus 0.5. And if you didn't do your reading questions, then your max score would be 4. Get your Infinite Campus completion score by taking the number you did out of 29 at pencil, divide, enter, multiply by 4, and then your reading question point. Please box nice and big your final Infinite Campus score rounded to the nearest half point, 0 to 5. What questions do you guys have on today's Infinite Campus score? Okay, pencils down, please, ladies and gentlemen. Let's go to our grading pens. And let's check our answers. And so we broke this up into several different blocks. In our first block, the application of an exponent to a base just means repeated multiplication. That's our definition of exponents. And so in simplifying each of those expressions, we get 16, 233, 890, 1,000, 890,000, and 115. And we'll be advancing soon, so please make sure you're checking. In our second block, we can practice with our properties. That is a power to a power, a quotient of powers, a product of powers, a quotient of powers, and a power of a power. Mark.
We were like on a test and we ended up with like something to the first power. Should we write it out or just leave it as it is?
You could leave that as 3 would be fine. The directions here wanted us to leave it as powers. So I know that 8 squared is 64. Because the directions said write it as a power, we wanted to leave it as 8 squared. On your quiz, I think we want to change 5 squared into 25. Now with variables, we can apply the same properties. And next slide. For number 40 and 41, we're not using any sort of inverse operations necessarily to solve these expressions involving powers. We're simply using our knowledge of our properties of exponents through guess and check or an inspection to figure out what value of the variable would make it true. In other words, when I multiply two powers together, like in number 40, 21 to the g times 21 to the 7th, my shortcut operation with the exponents is addition. So, in order to figure out what g would have to be, I say what plus 7 equals 15. Oh, g has to be 8 in order to make that statement true. And so we just solved that through inspection. 41, when I raise a power to a power, my shortcut operations with exponents is multiplication. And so y times 3 would have to equal 3 halves. What would y have to be in order to make that true? Oh, y would have to be 1 half, because 1 half times 3 is 3 halves. And our final slide. Okay, as you're finishing up, go ahead and give yourself an accuracy fraction. Out of those you did, about how many did you get correct? On side 1, the first page by your name, circle that in pen, make sure your infinite canvas score is boxed nice and big in pencil. Make sure they're facing the same direction, please. Name on top and pass from the back to the front. Side 1. Front rowers, please make sure they're facing the same direction. I appreciate your help. Everybody good with number 1 if you did it, number 1? Awesome, thank you. Okay, ladies and gentlemen, the next thing we're going to do is solidify our properties of exponents that you worked hard to develop in your cooperative learning group's last class. So at this time, I ask that everybody go ahead and find your green sheet, right, your green note sheet, the cover page. We're going to go ahead and get these exponent rules down together, and then we'll work to apply them for several examples together, and then you can apply them with your homework exercises with a partner. Okay, so you have a long assignment tonight, but you should have a block of time to work and practice together in partner pairs as you work and prepare for next class period's quiz. Here we go. So our definition of exponents. Everybody find your green sheet. Our definition of exponents, after you turn the cover page, the back side. Exponents represent repeated multiplication, right? Repeated multiplication. So if I have a whole number exponent, that's telling me the number of times that I'm going to multiply the base by itself. In this long form expansion, 2 times 2 times 2 times m times n times n times n, I could rewrite that with exponents to save time. My hand's getting tired just thinking about having to write that out every time that appeared in a problem or an equation, right? Instead, we can write it using exponents in a nice succinct package. 2 times 2 times 2 is 2 to the 3rd. M multiplied together by itself 4 times is m to the 4th. And so my definition of exponents represents repeated multiplication, and it's a handsome carry case. If we were to go the other direction and expand 4x to the cubed, that would be 4 times x times x times x. And lastly, for a stamp, a plus b, quantity squared, does not equal a squared plus b squared. Instead, it takes that base and multiplies it by itself, the number of times the exponent tells us to do. This would be a plus b in parentheses times itself twice. So a plus b in parentheses times a plus b. That's what exponents represent, their repeated multiplication. We know the base is the value that is being repeatedly multiplied. In the power, 5 cubed, right? 5 cubed is a power. The base would be 5. The exponent tells us the number of times the base is multiplied by itself. In the power, 5 cubed, the exponent would be 3. The power then is the base with an exponent. It has the two pieces. Base to the exponent is a power. So the power is 5 cubed. So the power is 5 cubed. It consists of a base and an exponent. In the power 5 cubed, the base is 5, the exponent is 3, and that would mean 5 times itself 3 times, or 5 times 5 times 5. Carson? Absolutely. Margot?
So like, if like the 4x cubed,
Yep.
that example, if you were asking for the power, would it just be x cubed or would it be 4x cubed?
X cubed is the power
Okay.
in the term 4x cubed. That's correct.
Okay.
4 is a factor, right? Is a factor in front with multiplication. The
Yeah.
power would be x cubed. Good question. Awesome. Everybody good with our first part? A little longer? Okay. The zero exponent rule is one of my favorite properties. A non-zero base raised to the 0 power is equal to 1. So 106.58 to the 0 is all 1. We could write that symbolically as any non-zero base b, call it, raised to the 0 power equals 1. The negative exponent rule, right, is super important. Negative exponents don't mean negative answers, they mean reciprocals. And so a to the negative n is equivalent to 1 over a to the positive n. Five to the negative third is equivalent to 1 over 5 to the positive third. And depending upon our directions, we could rewrite this as 1 over 5 cubed is 125, or 1/125th. In this case, I'll leave it as a power so we can see how we applied that rule explicitly. If we have a quotient raised to a negative exponent, we'll simply flip the base and raise both top and bottom to the positive exponent. That's our hop the line and change the sign. So when we apply the negative exponent to a quotient, we take the reciprocal and raise both to the positive exponent. So 4/5 to the negative 1 would be the same as 5/4 to the positive 1, which in turn is 5 over 4. Two-thirds to the negative 3 is a two-stepper. I'd rewrite that as 3/2 to the positive 3, and then apply it, that exponent of 3, the cubing, to both top and bottom. So that would be 3 cubed over 2 cubed, which in turn would be 27/8. So we'll get there for you in the back. So we take the reciprocal and then raise both to the positive exponent. So that becomes 3/2 quantity cubed, which is 27/8. our product of powers rule was our first rule you guys developed in yesterday's activity 1, properties of exponents. If I take two powers, call them x to the m and x to the n, and multiply them together, my shortcut operation with the exponents is addition. So x to the m times x to the n is x to the m plus n, and we saw that in your closure as well. X cubed times x to the first, right? If I were to expand that out, we can see this would be x to the third would be 3 x's, x to the first would be 1 x's. So I'm applying with the rule x to the 3 plus 1 for my first step. X to the 3 plus 1 is x to the 4. Margo?
What would, wait, are we doing this bottom one?
This one?
No, this.
No, we're skipping a fractional exponent rule. Is that fractional? Yep, we're skipping fractional exponents until we define them. Sorry, so hang on to this. We're going to come back to fractional, but we're skipping that for now because we haven't developed that yet.
Okay.
Now we're going to verify with the definition. The definition of exponents is repeated multiplication. So x cubed in blue is x times x times x times the single solitary x to the first in green is how many x's in a row multiplied together, Katie? 4. Guess what? Math works. So this is x to the 4th, whether I'm using the property or the definition of exponents. Next, a quotient of powers, that is b to the x divided by b to the y, I can rewrite as a single power by doing top exponent minus bottom exponent. So b to the x minus y. If I were to apply the rule m to the 5th over m to the 2nd, that would look like m to the 5 minus 2 or m cubed. So if I apply the rule, I do top exponent minus bottom exponent and rewrite as a single power. Could we verify that with the definition? Certainly. If I let this line be a fraction bar, on top I would expand m to the 5th out, and that would become m times m times m times m times m. I think I'm going to go have a little candy. And over the bottom would be m times m. After canceling out common factors, right, I divide out m divided by m is 1 over 1. M divided by m is 1 over 1, and I get 3 m's over 1. M times m times m is, you guessed it, m cubed. So whether I'm applying the property or I'm using the definition of exponents and reducing, the result is still the same, m cubed. So what can we do with our dot dot dots? When powers with the same base are multiplied together, keep the base and add exponents. So when powers with the same base are multiplied together, we keep the base and add the exponents. When powers with the same base are divided, we keep the base and subtract the exponents, top minus bottom. Top exponent minus bottom exponent. If we were to do top exponent minus bottom exponent, it's okay to get a negative exponent as an intermediate result. We would then go back and apply our negative exponent property last to rewrite with positive exponent. So it's okay if you get a negative number when you do subtraction when applying the quotient of powers. And we're closer with our properties. Power of a power, right? This was your 18 stamp, so power of power. If I take b to the x and raise it to the y, my shortcut operation with the exponents is multiplication. So b to the x times y. So w cubed all squared would be w to the 3 times 2. Applying the rule would be w to the 3 times 2. And that is equivalent to w to the 6th. And so if I raise a power to a power, my shortcut operation is multiplication. Let's verify with the definition. Using expansion, w cubed squared would be the base w cubed multiplied by itself twice. That would be w cubed times w cubed. W cubed is 3 W's. W cubed is 3 W's. How many W's do I have multiplied together in a row? 6. So either way, I'll get W to the 6th. When the base of a power is a power, keep the base and multiply the exponents. The power of a product, this is what we did for our discussion with partners at the beginning. If there are parentheses, then who gets raised to the exponent? Everybody in the parentheses gets raised to the exponent. So A times B, quantity to the y, is A to the y, times B to the y. Let's apply the rule. 4x cubed is 4 cubed times x cubed. Everybody in the parentheses got raised to the exponent, which in turn is 64x cubed. We can verify that with the definition. I know that 4x cubed means take the base, whatever it is, in this case 4x, and multiply by itself 3 times. So 4x times 4x times 4x. How many 4's are multiplied together in a row? 3. How many x's are multiplied together in a row? 3. So 4 cubed times x cubed equals 64x cubed. We can summarize this with words as follows. When the base of a power is a product, each factor is raised to the exponent. So each factor is raised to the exponent. Awesome. Powers of a quotient. If I have a quotient that is division a over b all to the x, who gets raised to the exponent? Both top and bottom. So a over b all to the x, let's try that. Y over 2 all to the 4th, who gets raised to it? They both do, so we have y to the 4th over 2 to the 4th equals y to the 4th over, and that's 16. We could verify with the definition by rewriting that as repeated multiplication. Y over 2 all to the 4th, right, would be y over 2 times y over 2 times y over 2 times y over 2. How do I multiply fractions? Straight across, comma, baby. How many 4? How many 4? How many 4 y? How many y's are multiplied together? That's right, 4 y's. So y to the 4th over, what's 2 times 2 is 4 times 2 is 8 times 2 is so big. Math works, and we've generated the same expression both ways, by applying the rule or by using our definition of exponent. So what can we say for words? When the base of a power is a quotient, both top and bottom are raised to the exponent. Both the numerator and the denominator are raised to the exponent. Or the exponent applies to both numerator and denominator. Olivia?
On the quiz, are you gonna have to like define some of this stuff, or is it just like doing that?
It's going to be applying it with the addition of even versus odd functions. And so the last thing we talk about today will be on the quiz. However, it's fairly short, and it already draws on your foundational knowledge from Unit 1. Even functions are like squaring functions, y equals x squared. And odd functions are like cubing functions, our disco, y equals x cubed, our down-up snake-like graph. And so the last thing that's on your quiz, we're going to discuss bless you next. Okay, let's go ahead and take a look at some more complicated examples. So everybody, let's get you 3 solid examples, and then we'll go ahead and add our even versus odd functions, and then you're going to have a nice chunk of time to work with a partner on your practice problems. Here we go. in example 1, notice how we have a mixture of exponent properties. We've got some parentheses, we've got some zero exponents, we've got some negative exponents. Let's go ahead and carefully apply our properties to get the same result. I'm going to go ahead and call this my green power. So in my green power, are there parentheses, Aaron?
Yes.
So who's going to be squared, right? Who's going to be squared if I have parentheses? Adam?
All of it.
All of it. The 4 gets squared and the x cubed gets squared. So my green power becomes 4 squared times x to the, in my shortcut operation when I raise a power to a power, right? What do I do with the exponents? Be ready to tell the class when I call on you. So when I take x cubed and I square it, when there's parentheses, power to a power, what do I do with the exponents? What do I do with those exponents? Braden?
You multiply the exponents.
Good. So my first green power is simplified to 4 squared times x to the 6th for my first step. Everybody, we'll go ahead and look at this next term, 3x to the 0. Are there parentheses? Dakota? No. So in the absence of parentheses, who does that exponent apply to? Jackson? Only the x. So that 3 still chilling. And then what's anything to the 0? What's x to the 0? Taylor?
1.
1. Blue power taken care of. Good job. Lastly, red power. So I've got a negative exponent. Does negative exponent mean negative answer? No. Negative exponent means reciprocal. I can rewrite that with a positive exponent if I hop the line, that is, go across a fraction bar, and change the sign, that is, rewrite with a positive exponent. So 2x quantity to the negative 2 is the same as 1 over 2x quantity to the positive 2. So everybody see our red power? Look at that. We hopped the line and changed the sign. Now look, we kept parentheses because both the 2 and the x were raised to the negative 2, weren't they? So when I rewrite it, both the 2 and the x must be raised to the positive 2, and that's why I kept parentheses. Now this is just my first step, okay? This is just my first step. Now we'll go ahead and do second step. I'll simplify easy powers like 4 squared. 4 squared is 16 times x to the 6th times 3 times 1 times 1 is just 3 all over. And now we'll go ahead and apply my exponent, this exponent squaring to the quantity 2x. Are there parentheses? Olivia? Yes. Who gets squared? Will? Everything. So 2 squared becomes 4. X squared becomes x squared. And now we're almost there. 16 over 4 times 3. I can reduce this as 16 times 3 is 48. Divided by 4 is 12. Alternatively, 16 over 4 is 4 times the 3 on top is 12. Either way, I get 12. And x to the 6th over x to the 2nd. Do I have more x's on top or on bottom, Luke? Top by how many?
4.
So my final answer is 12x to the 4th. You could also do that with subtraction. Top exponent, 6 minus bottom exponent, 2. What's 6 minus 2? 4. So either way is correct. So my final answer is 12x to the 4th. What questions do you have on example 1? Example 2, here we go. More complicated examples. For my first power, the blue power, right? Do I have parentheses? Barrett. Yes, so who gets squared? Katie.
Both.
Both top and bottom. Everybody in there is going to be squared. The 3 gets squared, right? The n gets squared. The 4 gets squared. So I've rewritten that blue power without parentheses. Everybody see it? Next, green power. Are there parentheses on the green power? Logan? No. Who does the exponent apply to? Katie? Good. So I leave the 4 just chilling. That's not going to change, right? That's not going to hop the line and change the sign, but the n is. This becomes n to the first on bottom. Everybody see that? The negative exponent only applies to the m, so that's the only one we're going to hop the line and change the sign on. The red power. The red power. There's parentheses. So who gets raised to the 4th? Everybody, top and bottom. That's 1 to the 4th, which is still 1 over m squared to the 4th. When I raise a power to a power, my shortcut operation is multiplication. So my red power simplifies to 1 over m to the 6th or 8th. 8th. We multiply exponents. Good job. And then I still have the times m to the 6th on top, just chilling. That, right, doesn't need to be simplified anymore. All right, how do I multiply fractions? Straight across. So let's rewrite as one big fraction as our next step. One big fraction. So 3 squared is 9 times 4 times 1 is that, m squared times m to the 6th all over 4 squared times m is 16. M to the 1st times m to the 8th, m to the 9th. How do I want to do this? How do you guys want to do this? I think I want to reduce the 4 over 16 as 1 over 4. So 9 over 4. And do I have more m's on top or on bottom? Well, that's 8 m's. So isn't that blue, m to the 8th? Over m to the 9th? Do I have more m's on top or on bottom? Margot? Bottom by how many? 1. So my final answer is 9 over 4m. That was pretty sweet. So we've got m to the 8th over m to the 9th is 1m on bottom. If you did that out and did 36 over 16, you could divide out the common factor of 4 and get 9/4. What questions do you guys have about example 2? Ben?
You move the thing, it's the covering.
So we're just saving the fractional,
Nope.
the fraction.
Nope. Oh, yep. So number 3, or the fractional exponent property. No, there is 2. Yeah. The fractional exponent property we're saving.
Alright.
We haven't defined fractional exponents, so hang on to
Are we
that.
doing this today?
Nope. And that won't be on your quiz. Today we're going to do even versus odd functions in our last discussion, and then you'll have an opportunity to practice applying the property.
Did we get you these green notes like we did last
Nope,
week?
you won't be able to use the green notes. They're just green to say, hey, these are important. And you can use them as a reference, right? As you work through your homework exercises, you should know this stuff and don't lose it. That's what the green means. No, you won't be able to use them during your tests or quizzes, right? As we continue moving up in your mathematical careers, you won't be able to use the green sheets during your tests or quizzes. Okay, we're going to test that you know these properties. Awesome. Let's go ahead and finish up our discussion then with even versus odd functions. I want you to think back to our basic functions unit. When we had our first green sheet, Margot, on our first green sheet, we had several parent functions. Some of them involved exponents, right? So what I want you to do is go ahead and tell your partner which of our basic functions included exponents, and be ready to share with the class. We had several of them. So what was one parent function that included exponents? If you need to look back, you can. If you need to look back, you can. In your green sheet, your first green sheet.
X squared,
Squaring function.
1 over x squared, square root of x squared, and cubed x.
All right. What's one? What's one function that involves exponents? Carson. The cubing function, y equals x cubed. Good. A different one that involves exponents. Logan. The squaring function, y equals x squared. Raise your hand if you came up with a different one. A different one, Ben? The square root of x actually does involve exponents. It involves fractional exponents that we haven't defined yet. And so, Margot, that's what we'll be defining soon. And so, the square root of x actually does include exponents, but we haven't written them that way. I'm going to hold off on the square root of x just right now. Carson?
Inverse squaring function.
Yeah, our 1 over x squared had exponents. Good. Others? No? What about our identity function, our second one? Isn't y equals x? What's the invisible exponent on this function?
1.
1. And so our identity function is actually an odd. We'll find out that to be an odd power function. Its exponent is 1. And so that is a function definition that involves exponents. Any others? Heather?
That one, squaring one, wouldn't the reciprocal one be?
Absolutely. So since x to the first involves exponents, so does 1 over x to the first, the reciprocal function. Good job. And there are more, okay? So the square root function is included. Y equals square root of x is included, but not yet because it's a fractional exponent. What we're going to do is go ahead and consider how the exponent affects the behavior of the graph. So everybody on your note sheet, we printed this out for you. This is a nice summary and synopsis of even functions versus odd functions. If my exponent n is even on a power function, y equals x to the n, then all even power functions share these qualities. They appear in the even quadrants, left, right, bilateral symmetry. So we've got quadrants 1 and 2 for my basic y equals x to the n. Points on the graph have reflectional symmetry about the y-axis, the vertical line x equals 0. For example, if 1, 1 is on the graph, guess what? I know that negative 1, comma 1 is also on the graph. If, do we have any others in here? If 2, 4 is on the graph, then I know what other point must be on it. Negative 2, 4. And so I can change the x-coordinate sign and then pair it with the same y-coordinate because there's reflectional symmetry about the line x equals 0. The range is the collection of all non-negative outputs. The appearance is in quadrant 1 and 2. When n is odd, like the cubing function, then my appearance is rotational symmetry about the origin, 180 degrees. Now, if I had the point 3, comma 3, what is the scale? 2, 8. I don't know what the scale is. If I have a point on the original function, I'm going to go ahead and do 2, comma 8, even though it's not
That's
there.
weird scale.
I know. We'll go ahead and flip the signs on both the x and y coordinates. If I spun this 180 degrees about the origin, rotational symmetry, then I know it would fall upon its own image. What other point must be on here? Negative 2, negative 8. The domain and range are all real numbers for an odd because they go forever in both directions towards positive infinity and negative infinity. Let's go ahead and, for each graph, state the domain and range. In what quadrants does the graph lie, and make a quick sketch. So here we go. Y equals x to the 4th. Is the exponent even or odd for my first graph? Y equals x to the 4th. Casey? Even. So is this going to look like the squaring, or is it going to look like the cubing? Carson? Squaring. Good. So my basic graph without a scale is just going to be a bowl shape. The domain, right, for all power functions is all reals. The range, however, for even power functions is restricted to only non-negative. So y is greater than or equal to 0. And in which quadrants does the given graph lie? You can see 1 and 2, the top quadrants. Y equals x to the 5th. Is that an even or odd exponent for y equals x to the 5th? Olivia H. Odd. Is this going to resemble the appearance of my squaring bowl shape or my cubing disco shape? Mark.
Would be the U.
If it's an odd power function, if it's odd, it's going to be the disco, right? Because it's odd in behavior. It's going to look more like the cubing function. Okay, so let's go ahead and sketch that in. That would look like this. All reals is the domain and range for any odd power function. All reals, all reals. The quadrants in which it appears, however, are the diagonal quadrants 1 and 3, as opposed to the top quadrants 1 and 2. Y equals x to the 6th, bowl shape or disco? Jackson?
Well,
Bowl shape, total bowl shape, watch your language. How come? Why'd you say bowl shape? Absolutely, even exponent. Thank you, that's perfect, Jackson. So even. Again, all reals for my domain. However, restricted range, only non-negative outputs. So y greater than or equal to 0. And again, quadrants 1 and 2. Last one is y equals x to the 7th, going to look like my squaring or my cubing. So y equals x to the 7th, will that look like my squaring or my cubing? Olivia B?
Cubing.
Cubing, good. So this would be a down-up disco. All reals, all reals. Odd power functions have all reals for the domain and their range. However, their appearance on the graph is just the diagonal quadrants 1 and 3. What questions do you have about even versus odd power functions? Okay, now you're going to work with your partner to complete the examples on the note sheet. We did it, so you're checked. We've already done that. But the problems from the assignment sheet out of the book, that is a whopping assignment, so you've got a nice chunk of time to work on that. And then study for your quiz covering lessons 7.1, 7.2, and 7.3. But first, let's take care of our closure, and then you'll have the rest of the time for work. So I need you guys to write down a single power that's equivalent to x to the m over x to the n. Rewrite that as a single power without parentheses. Rewrite a over b all to the y without parentheses. What would that look like as you apply that exponent? Would that apply to the top or the bottom, or both? Rewrite number 4 without parentheses or negative exponents. Number 3, rewrite without negative exponents. And then I just want a general shape for even exponent n versus odd exponent n, and the power function f of x is given by x to the n. Make sure I can see your closure response on your page as I walk around, please. And then I'm going to have you share on the whiteboard. Okay, let's rewrite number 1 as a single power. Please share your response with the class when I call on you. Number 1, Luke. X to the m minus n. Nice job. Raise your hand if you have the same as Luke. X to the m minus n. We subtract top exponent minus bottom exponent. Good job. Number 2, without parentheses. Taylor?
A to the y and over b.
Good. That exponent applies to both numerator and denominator factors. Raise your hand if you have a to the y over b to the y. They both get raised to the exponent. Good job. How would I write number 3 without a negative exponent? What would that look like? Heather?
1 over k to the power of
Good job. 1 over k to the positive p. Raise your hand if you had the same as Heather. 1 over k to the p. Good job. And then number 4, all right, how could I rewrite that without negative exponents or parentheses? How could I rewrite that? Adam? Good job. Notice how Adam flipped the base. He made it y over n. That was applying the negative. And then the exponent would apply to both numerator and denominator in accordance with our power of a quotient property. So y to the n over x to the n. Good job. General shape if n is even. Tyler?
It's a bowl shape.
Bowl shape. Good job. And general shape if n is odd. Mark?
The disco.
Good. Looks like the cubing. Down, up, end behavior. And guys, just so you know on your quiz, right, you want to make sure that you're doing quadrant 1 and quadrant 2 is the appearance of even, and then quadrant 1 and quadrant 3. Does everybody see that? Right? For your parent function that's odd exponent. Great work today. The rest of the time is going to be yours. There's a stretcher for good measure for those of you who still need a little challenge. You may work quietly with a partner, and I'll go ahead and save the recording. Nice job today. Don't forget your quiz next class.